Good evening all. Today I'm going to do a slightly different video format as I used to do. I'm not going to stand directly in front of the camera because I think that's something I still need to get used to. So I'm going to do a bit more of a visual presentation for my projects, and this is my first project build video, which is video number 3, and it's the bench power supply version 1. So essentially what it is, it's a bench power supply that delivers four different voltages. So it will be, V out will be 3.3, 5 volt, 9 volt and 12 volt. Yeah, so that's the premise of my video, and I will explain to you exactly how I put it together and how it works. So let's get started. Okay, so as you can see in the schematic, the basic operation is you have an AC power source, which is your AC mains, and that goes into the an AC to DC switch mode power supply, which is a pretty standard off-the-shelf like LED driver, or just a 12 volt power supply that delivers about 2 amps. So it's my switch mode, power supply, and then the output from that is 12 volt DC, which gets fed into 3 separate buck converters. So this is a buck, and each buck converter is adjustable. So I've adjusted the first one to be exactly 3.3 volts, or roughly roundabout, and the second one I've adjusted to 5 volts, and the third one I've adjusted to 9 volts. And then to get 12 volts out, I just feed the output of the 12 volts straight to my outputs. So all these outputs are connected to binding posts, which I also got very cheaply off AliExpress or Banggood or eBay. And same as the buck converters, the power supply I also got from pretty much the same source very cheaply online. Yeah, so that's a pretty straightforward, very simple project you can put together at home. It's extremely compact. I mean, these power supplies are literally no bigger than this pen, and the buck converters are actually a little bit smaller than these. So you can imagine that your enclosure will be maybe no more than that big, which is really convenient because then it takes very little space on your bench, and it supplies all the most common voltages that you need. 3.3 volts for your microcontrollers, 5 volts for other microcontrollers and sensors, and 9 volts for all sorts of instruments, or if you power things through a 5 volt linear regulator, you'd probably supply 9 volts. And then 12 volts, you might power a strip of LEDs, or maybe power an audio amplifier or something like that. So it's quite flexible in that regard. It's very compact. It has preset outputs, and you just plug it in and you go. There's no like adjustment knobs or setting the right voltage. And the beauty is, as well, is that they're all separate. So in theory, you could be powering at least 4 projects, you know, at the same time while this thing is running. The only thing you'd have to consider is that the output of the 12 volt power supply that I chose is only about 2 amps. So 2 amps. So you get roughly 24 watts out of that, so, which is your total power budget that you can output. So you know, you can only use the different buck converters together as long as they're equal to less than 24 watts. If it exceeds that, it's likely that your main power supply will trip out. It'll just have a overpower, overload, and it will reset itself. So you got to be careful of that behavior, that you don't draw too much power, because then it'll reset the power supply every time there's an overload scenario. So yeah, as long as you keep it within that range, you'll be good. Just another thing you note is that they're all switch mode operations, so you're going to have a lot of switching frequency, output ripple, which is quite normal for switch mode power supplies. So you know, if you power sensitive equipment like op amps or amplifiers, make sure to use some kind of a ferrite bead or a noise reducing component or circuitry to reduce the output ripple. Like something like a linear regulator, they do a pretty good job to really reduce the output ripple to a manageable level. So yeah, that's the theory of operations. So let's have a look at the actual project that I put together. Okay, so here we have the enclosure that I put all the components inside, and I'm just going to go over the basic layout. It's actually, compared to the schematic, it's virtually the same as what you can see here. So here you can see the main 12 volt power supply. The board number is IC012. It's from my analysis, it doesn't seem to be the best component selection. From what I can see, it doesn't have a input filtering or safety capacitor on the front. It does have a common mode choke, which is pretty standard. Then it's got the bridge rectifier in there, the main filter cap, and some of the switching circuitry in there. Then you got all the binding posts from the power supply that I've linked up that go through to the individual buck converters. See, I've marked that one there with a 3, marked that one with a 5, and that's a 9 volt one. So these buck converters are pretty small. They supply about 1.8 amps or about 2.5 max, but you probably get a bit of voltage dropout at that level. So, you know, safely, quite reasonably, 1.5 amps from each of these buck converters. Yeah, and then that's the basic layout. I actually put a little cutout at the back as well, with a little grid, so you got some air flowing through there, because they can heat up a little bit, these components. So let me go over basically the outside construction. I printed out and laminated a front panel with the printed numbers on the front. I've mounted the binding posts directly above each other, so that's 12 volts and that's ground for that 12 volt, and then the same for the 9 and 5 and 3. I mounted the main power switch, so that's the AC power switch, which is the AC mains power switch that switches the whole unit on and off. at the back I put on a normal type mains cable gland, mounted that in so it's secure and the cable won't pull out. Got some little rubber feet, so it really sits firmly on the surface. You know, so you can see kind of a comparison of size to how big it is. I mean, this is my pen. It's actually quite small. I mean, it fits basically into my hand, which is really useful. And then, as a nice feature, I just printed out the specs on the side, just so that I don't forget sort of what the limits are and you know, the maximum ratings and things like that. So you know, you can forget about this project in the next 10 years and come back to it and you'd be like, oh, I wonder what this thing can do, and it's written on there. So yeah, you don't have to worry about remembering. Yeah, so that's basically it. So just a side note, I did want to show you some test results for the actual characterization of each of the buck converters or each of the outputs with an electronic load, but I don't have that equipment on hand today, so I'll post a follow-up video that gives some test results that'll show exactly how much power you can get and see at what point it starts to droop, and see the actual capability of that and see if it kind of compares to the specified ratings of the actual devices. Yeah, so I have done a very rough test before, but I thought it's not really worth posting that on the web right now because it's not really scientific. So yeah, hold on for the follow-up video, and I'll have that ready once I've built the one of my next projects that's coming up is an electronic load. So once I got the load project done, I'll actually use it to test this power supply. Anyways, thanks a lot guys for watching. Yeah, drop any comments. Please like the video if you liked it, if you want to see more of this kind of video, and yeah, subscribe. Thanks a lot for watching. Cheers guys.